Oh, good. I got two people who love trig. Or one and a half. One is so-so, one says yes. So the rest of you don't like trig. Good. We're going to use a lot of trig in this class. But the good news, you only have to know a few things. Sohcahtoa. Sohcahtoa, some Indian chief, I guess name was Sohcahtoa. I don't know what his claim to fame was. Why am I supposed to know his name? I don't know that. You can Google that too. But if you have a right triangle, let's draw one. There's my triangle. Let's call this angle theta. We have three sides to this triangle. This is the only side that's not touching the angle. See it? That's the opposite. Then there's two sides touching the angle. Which one do you think is the longest side? Yeah, which is the top one. That's your 90-degree angle. That's your hypotenuse. That leaves this side to be what? The adjacent. We have more than 3 trig functions. I'm only interested in 3 of them. The sine of theta, and the way we write that, S-I-N, not sin. I've seen people say sin. We're not committing any sins today. Nope. That's the sine of theta. And that's where Sohcahtoa comes in. O for what? Opposite. And H for what? Hypotenuse. So it's this side over that side. The cosine of theta. That's the cos of theta, which is A for adjacent and H for the hypotenuse. And the tangent of theta, and we write that tan theta equals opposite over adjacent. If you know 2, you can find everything else. If I know this side and that side, I can find the angle, I can find the other side. If you know 2, you can find the rest. Let's see how. And before I actually leave this subject, there is a relationship between this side and these two. Something called what? Pythagorean Theorem. Remember that? If I call the hypotenuse C, I call one of these A, one of this B, then we have a rule that says what? C squared equals what? A squared plus B squared. So if you know these two sides, you can find that side. Just a few things. Can I also find theta if I'm looking for C? If you know A and B, can you find theta? So this is given A and B. If you are given A and B, can you find C? Can you find the hypotenuse?
Yes.
Yes. Can you find theta? Yes, it's the inverse tangent. Inverse tangent. Tangent is opposite over the adjacent, B over A. The only thing I will remind you that if you use your calculator, you're going to get the wrong answer. If you are in quadrant 2 or quadrant 3, add 180 degrees to your answer. if in quadrant 2 or 3. If you are in quadrant 2 or 3, if you just use this one, the calculator will give you the wrong answer. You have to add 180 degrees to it. So let's take an example. Your friend goes hiking. Ask you to go with them. Go, no, I'm not really interested. Hiking is not my type. That's why we have cars. We drive there. But, so where are you going? So, I just found this place. I'm going to go to Mount Tom. I'm going to go 8 miles this way. Then there's a road that goes straight up. I'm going to go 12 miles this way. They're hiking. 20-mile hike. Now they have a problem there. They pick their cell phone, they call you. I need help. I got hurt. Well, now we're going to send a helicopter to go and get them. We're not going to wait for that. Somebody's injured. So the helicopter needs to know which direction, because we're going to send the helicopter straight in that direction. We're not going to tell the pilot, go 8 miles this way. When you get to that corner, turn, go 12 miles. That's silly. We're wasting time. So what is the length of that distance? How far the pilot has to go? And what heading? Assume there's no wind. What's that angle? We should be able to get that. How do we get what C is? C equals what? Or C squared equals what? A squared plus B squared. C squared equals what? 8 squared plus 12 squared. 8 squared is what? 64. 12 squared is what? 144. Let's add them. 208. And what is C equal to? The square root of 208. 14.52? 42. So 14.42, or, I'm not paying attention to significant digits because I want to rescue these people. I want the pilot to go 14 miles and find out there's nobody's there. Another 0.4 miles farther. So 14.4 miles in that, you're going to travel. Now I need to give them the heading, which direction to go. So theta is going to be what? The inverse tangent of the y value, which is 12, divided by the x value, the adjacent, b over a. The y over x. So what's the inverse tangent? 12 divided by 8. And I'm going to tell them to go 56.3 degree heading. So the pilot will leave out of, I don't know if it's a hospital, out of Bay State Hospital, put in the GPS 56.3 degree heading, go 14.4 miles, and you should find them right there. So if I know these two sides, I can get that side and this angle. I can always also work backward. If I know this and this, I can find these two. Let's say you live next to Westover. You've seen these C5 taken off. So here's the C5. Big, massive plane. It's taken off. At takeoff, the speed is not really that fast, but we'll give it some number. It's taken off at a speed of 210 miles per hour. It won't be at that speed for a while, but let's say it was reaching there. At an angle of, comfortable angle of incline is 10 degrees for a plane, so 10 degree angle. Now, if you are mowing the lawn, you'll see the shadow on the ground going like this. Right? You're looking at the ground, you see that shadow moving under you. How fast the shadow is moving in that direction? So if you make your triangle here, can we get this side? We know this side, the hypotenuse. We know the angle. We're looking for what? What's this side, the opposite or the adjacent? Adjacent. So which actually value I should use to get the x value? If this is the x direction, to get the x value, x component, cosine. Yes. So I'm going to get that by taking 210 times the cosine of 10 degrees. Or another way of saying it, r, if this is r, and this is theta, it's r cosine theta. There's a whole chapter on this going to it. And that'll give me the x value. That's how fast the shadow is moving. What's 210 times cosine 10 degrees? 206.8. That's roughly 207 miles per hour. Because the angle is really small. Now, if somebody is, let's say, 20 miles away or 30 miles away in Pittsfield, Mass., they see the plane taking off. They don't see it moving. All they see, the plane is rising. So to them, how fast is it rising? What's the speed that's climbing up in the air? That's the y value. So how do you find the y component? That's what? The opposite? That'll be what? R sine of theta. (210) times the sine of 10 degrees, and that's 36.5 roughly miles per hour. So how fast the plane is rising, going straight up in the air? If you're watching that, speed of 36.5 miles per hour. How fast the shadow on the ground is moving is 207 miles per hour. Now, I'm not counting for the wind, because the wind will change everything. Don't worry, there's a whole chapter on that too. We get chapters on everything.